Hi friends, welcome back to the JK Biology, and today I will solve a big questions related to the transformations, restriction digestion and restriction mapping. Okay, so there is the questions that can be asked in the CSIR, that is the big questions related to these patterns of the questions can be asked within the CSIR. Okay, so this is the questions. Follow. Let me solve these questions. What is saying the questions for the restriction digestion of the plasmid? There is the also term transformations. If you do not know about the transformation, then go back to the JK Biology and see the transformations, then come to the these questions. Okay, so the for simply in brief forms, I say that transformation means foreign particles can be transformed within the bacterial plasmid. Okay, that is called transformations. So the questions say, come to the points about the questions, that say you are attempting to clone a linear DNA fragment. What is a linear DNA fragment? That is the linear DNA fragments. You want to clone these linear fragments. Where? Within the plasmid of the bacteria. This is the plasmids. Plasmids become circular. Okay. So DNA fragments into a circular plasmid. The sites at which a number of restriction endonuclease will cut are indicated along with size of the DNA between the sites. The question is saying you are attempting to clone a linear DNA fragments into a circular plasmid. Okay. The sites at which a number of restriction endonuclease will cut are indicated. That is BAM-H first sites, EcoR first sites, and that is BAM-H and different sites within these fragments. Okay, so indicated along with the size of the DNA between the sites. For this experiment is performed. He said that for this experiment you linearize the plasmid. What linearize? If you add BAM-H first or EcoR first, then what happened? It will cut within the DNA and that's become linear forms that get to linear form after cutting. Okay, that's you will see here that they become linear. So after restriction digestions by the BAM-H first, and also it can be linearized by the EcoR first. But the question says here, for this experiment you linearize the plasmid with BAM-H first. Point out, BAM-H first mix with the linear fragment, mix with the linear fragments which also has BAM-H first cut, which also has BAM-H first cut. Point out, BAM-H first cut. Sites at the ends, Add DNA ligase. What? The function of DNA ligase. DNA ligase add the two fragments. It is also a big topic about the DNA ligase. Different types of the DNA ligase is available for the ligation, that is DNA first to fourth. So it is another topic. Then come only know in the brief that DNA ligase add the foreign DNA. Okay, and transform bacteria. Transformation technique is another technique. That is another process, but brief I have described from you that this foreign particles or foreign DNA fragments will be transformed within this plasmid by cutting with the restriction endonuclease, and then ligation would occur by the DNA ligase. Okay, but there is a question that how we know that the transformation has been completed successfully or not. That is questions. So there is the two method to solve this problem, that is blue-white selections. Okay, blue-white selections, and another is restriction digestion. So here is asking only about the restriction digestion. Say in the questions, DNA ligase transformed bacteria, you manipulate the plasmid DNA from colony. The question says that transformed bacteria, you manipulate the plasmid DNA from colony. That means when the colony is developed, transformations occur. When transformation has been completed within the bacteria, the bacteria will divide for the overnight. A number of bacteria will divide. With dividing bacteria, the plasmid numbers also increases. Each plasmid go to the next progeny of the bacteria, and so there is number of plasmids can be obtained by the number of bacteria. So here say that you mini prep the plasmid DNA. When the number of bacteria will grow till overnight, then we isolate total plasmid from the total bacteria. That's say you mini prep only the plasmid DNA from colony. Okay. After transformation, let's say after transformation we isolate or mini prep the plasmid. Total plasmid will be isolated. Then blue white selections was not available for this experiment. Okay. So you need to perform restriction endonucleate digestion analysis. He say restriction endonuclease digestion analysis need to perform. Then the question is how many numbers of fragments by BAM as first digestions with size in kb. There is a question how many number of fragments by BAM as first digestion after transformations, how many numbers of fragments will obtain with size in kb. And the second question is how many number of fragments by eco R first digestion with size. Two questions. And the third question says how many number of fragments by mixing with BAM as first and Hind third. How many numbers? If we cut by mixing with BAM as first in third digestion, how many number of the fragments will obtain with size in kb? There is three questions. You can also make many questions that if we mix all BAM as first, Hind third, eco R first, and then what is the number of fragments with size in kb. And there is also restriction mapping can be asked in the questions. What is the restriction map? Okay. So see these questions and I will solve these questions, all of these questions. So first, that what is the transformation and how transformation takes place. Okay. So there is the fragment. There is fragments. Hey, say that BAM as first digestions. Digestions. What happens? This will linearize. Okay. This will linearize, and if a transformation has been completed successfully, point out if transformation that plasmid this is here. Okay. That is plasmid. Point out this is plasmid. I take whole this plasmid and put up within this, and after transformation the ligations of DNA fragments have been done. Then what would be the size? Point out this is here, and after within this point out again I am for short terms this is fragments. Okay, add here, and I am showing here this process of adding. Okay, this is short. I am showing this in short forms, but this is here. So what is condition? Eco R1 is here and this is here. 3 kb of the plasmid, 0.75 contains BAM as first and eco R1. 0.75 kb of this restriction side fragments is here. Okay. Then 2.25 kb. Point out if 0.75 for restriction digestions is here, then the remaining length would be 2.25 kb of this plasmid. 2.25 plus 0.75 is equal to total 3 kb of the total plasmid length. Okay. So here point out this is orientation, also a term orientation. I will solve this. Same, this plasmid will add to this DNA fragments, then that is BAM as first. Okay, that is BAM as first, and here the remaining is here. Point out what is this? This is echo R first. This is echo R first. Why? This is restriction mapping. When the plasmid goes here, this is BAM as first sites. Okay. This is BAM as first sites. Adding. Then what happened? The echo R first site of that plasmid will be here. Will be here. Echo R first sites. Okay. Are you getting me? Then there is also this is BAM as first site. As first 0.75, and this will be 0.75 here kb, 0.75 kb. Okay, 0.75 kb. Then question says number of fragments by BAM as first digestion with size. This is in case of first orientation. If the plasmid will be the same, but there is first orientation. I am saying first orientation. Okay. What is the orientation? Because the plasmid, if same length of the orientation added in these forms, then that is the first orientation. Suppose that plasmid would be adverse, or this is in these conditions, then the fragments would be adverse. Point out here, the fragments would be adverse. This is 0.5 kb here, but after adversing, the 0.5 kb would be here, and 1.25 kb would be here. That is second orientation. Focus on this. Focus on this, that in the first orientation there is the fragments, the plasmid will add in the same way, then that is the restriction mapping. BAM as first 1.25 kb and echo R1 is here 0.75 kb. 0.75 kb. Again, I am showing you, that is BAM as first and 0.75 kb of echo R1. Okay. The orientation when add in these forms adverse, so I am drawing of this plasmid in that conditions. Echo R first. Okay. So 0.75 kb is here. Okay. 0.75 kb is here. Two orientations. The transformation can be completed in two ways, that these fragments will be added with the same here with the plasmid, or in another conditions the length or the fragments could be adverse and added in the plasmid in that orientation. That is, you can say here is this orientations after that 0.75 kb, 1.25 kb, 0.25 kb and 0.5 kb. But this first orientations 0.75 kb, 0.5 kb, 0.75 kb, 1.25 kb from this orientation. Okay, and from these orientations 0.75 kb and 0.5 kb. Okay, are you getting? That's the orientation is changed. This is second orientation of transformation. Okay, so what happened if we add BAM as first digestion? What happens? So if added BAM as first, okay, there is BAM as first, there is also BAM as first. Point out BAM as first. Then there is the size is 2 kb. The length of this fragment is 2 kb. The BAM as first cut here. BAM as first. Point out again. I am denoting with the red marks. BAM as first. Okay. Then these fragments will obtain in the first orientations. Point out this may be complex if you not understand easily. This may be complex. If the ligation would occur in these orientations, then the plasmid will obtain like this. Total length of the plasmid will obtain like this. If the orientations or ligations occur in this orientation, point out that only one orientation will take place in single time at the time of transformation. Okay, single time. So there is first orientation, and in this condition BAM as first is added, then the fragments will obtain of this plasmid is 2 kb. This is the 2 kb. BAM as first, that is 2 kb plus 3 kb, because we are not adding EcoR first. The total length of the plasmid is 3 kb. So there is the remaining parts here. The only remaining parts is 3 kb. Okay, this is 3 kb. Okay. Then what happens? Plus 3 kb after digestion with the BAM as first. Two fragments will obtain 2 kb plus 3 kb in the first orientations if the ligation would occur in these orientations. Okay. And another way, if ligation occur in this orientation, then what will be the fragments? By digestion with BAM as first. This is also BAM as first, but there is not another site for the BAM as first, either here or either here. That is EcoR first, and that is also EcoR first. Okay. Then also in these conditions, there is 2 kb fragments, there is 3 kb fragments. First orientation, second orientation, 2 kb plus 3 kb. Okay. So the answer is the number of fragments by BAM as first digestion with size would be 2 kb plus 3 kb in the first orientation, and if added in second orientation, then also 2 kb plus 3 kb. This is the answer of first questions. Okay. Come to the second questions. By EcoR first digestion, this is also complex for you. EcoR first. If in this orientation we take the EcoR, okay, EcoR, there is two sides for EcoR, okay, there is two sides for EcoR, here is 0.75 kb, okay, that is 0.75 kb, and here is 0.5 kb. Then in the first orientation, what happens? This will cut from here to the here for the EcoR1, here and here. What happened? Point out of this orientation. Only I am taking first orientation and Again we'll come to the second orientations, but first solve for the first orientations. Restriction digestion with eco R first. Here is eco R first. There is these fragments will have 10, this fragment will have 10. Okay. Then the fragment would be here. Point out the fragment would be here 0.5 kb plus 0.75 kb, because there is BAM-H first site. BAM-H first site, point out. So in this condition, he said that only eco R1 is added, not BAM-H1 is added here in this condition. So there is not digestion would be occur. Okay. There is only in the second question eco R1 digestions occur, not add BAM-H first. Point out, not add BAM-H first site. So there is not restriction digestion. So this will remain without digestion. So the length would be of eco R first is 0.5 kb plus 0.75 kb. Okay. So there would be 0.75 plus 0.5 kb. What happens? 1.25 kb length. Okay. The total length would be 1.25 kb. Okay. 1.25 kb, that is one fragment, and another fragment is remaining here. 0.25, 1.25 kb and the remaining fragments. Okay. 1.25 and 0.25. What is 1.50? 1.50. Okay. And there is 2.25. 2.25 plus 1.50. What will be? Total 3.75 kb. Focus on this. Take care that there is total length of 3 kb and also this is 2 kb of the insert of the DNA, foreign DNA fragments, of the foreign DNA fragments. So when you add 1.25 kb, 3.75 kb should be complete for the 5 kb, because 3 kb of the plasmid, 2 kb of the fragment. 3 plus 2 equal to 5 kb. Okay. Then by the eco R first, the length would be obtained 1.25 kb and the remaining part till here. Point out, remaining part till here would be, remaining part till here. Till here would be 3.75 kb, because 1.25 kb, 0.25 kb and the remaining 2.25 kb, total 3.75 kb in the first orientation. Okay, this is the first orientation. Then what happens? 3.75 kb plus 1.25 kb. Okay, in the first orientation. In the second orientations, what happened? If we add in the second orientation by the eco R first, what happened? That is, point out, this is orientation here. Okay. This is complex. Don't worry. If you try, then you will get easily to solve these questions. Okay. So, in this orientation, we add eco R first, then there is eco R1 hair sites and eco R1 hair sites for this. For this is also eco R1. Okay. This is also eco R1. Then it will be cut from here to here, from here to here. Point out, from here to here. Then the length 0.25, 1.25 and 0.75 kb. 0.75, 1.25 equal plus 0.25. 1.25, 0.25 equal to 1.50, then 0.75 equal to 2.25. 2.25 kb in the second orientation. So, okay, you can also draw 2.25 kb here, 2.25 kb from here to here, and the remaining part, what happened? The remaining part would be another fragments, that is 2.75 kb. Okay, you can calculate the remaining fragments as like 0.5 kb and then 2.25 kb. That is, there is 2.25 kb from here to here, 2.25 kb. Okay, and that is 0.5 kb. The length would be 2.25 kb plus 2.75 kb of the echo or first if second orientations ligation would occur by the echo R1. This is first orientations. So, in the first orientation, that is the fragment of 3.75 kb plus 1.25 kb. In the second orientation, 2.25 kb plus 2.75 kb. Okay. Then, again, biomass first and heme third digestions. There is the questions. We had biomass first and heme third digestions for the two orientations. That is the first orientations, that is the second orientations. This is the restriction mapping